what I've been up to and how my experience at Yale has played a pretty big role in my career. So after Yale, I majored in applied math and statistics at Yale. I went to UCLA, got a PhD in statistics, and then went to Johns Hopkins University where I'm a professor of biostatistics. So what it means is that I'm a statistician, right? You do that much statistics, they start calling you a statistician. But then recently, about 5 or so years ago, I learned that I'm actually a data scientist. And they forgot to tell me, right? And so at first I was a little bit annoyed, but then I realized that when I tell people I'm a data scientist, they actually listen to me. Just like they're all listening to me right now. So the funny thing is, it's like, it feels a little bit like being a software engineer in 1999. It's a really hot field, it's really popular. My students are going off getting jobs, getting paid twice as much as me, So, but the difference now is that data is kind of popping up everywhere. Everywhere you go, we're probably producing data right now. I mean, it's somewhere happening. And so everyone is kind of confronted with it. And so, in some sense, everyone is a data scientist. So, they forgot to tell you too, actually. And so, the problem for me as a professor of biostatistics is that I have to teach all these people, and I have to teach them all how to do data analysis. And the problem is that it's a lot of people. We put an online program on data science about 5 years ago, and in the time since then, 6 million people have taken it. So that's a lot of people who want to learn about linear regression models. It's like, people that really are interested in it. And so one of the problems with data science is that it's a kind of a fresh new field. And like any new field, everyone's just kind of flailing around trying to figure out what it's about. And it doesn't have a core foundation, and it doesn't have a clear identity of what does it mean to do data science, and what are the core kind of principles of data science. And so it makes it hard to teach. So one of the things I realized at Yale, I think we often complain about, why are these professors always teaching us this theoretical stuff and it's not that useful? But I learned now that the reason that's true is because the theoretical stuff is the only stuff that you can really teach in a classroom in front of hundreds of people. If you want to solve real problems, you have to kind of get into the nitty-gritty details of each particular problem. And that doesn't really lend itself to a lecture of 500 people, right? But the problem with data science is that it's all nitty-gritty details. It's just that everything is about different models, different data, different algorithms, things like that. And so how do we kind of generalize across all these separate problems and try to come up with some kind of core foundation in the field? So, so this is kind of where my experience taking all these music classes comes into play. Because I didn't think that all these atonal theory classes would actually come in handy, later on in my career. But it turns out they did. So one of the things, I'll get to that in a second, but one of the things that I learned as I became a professor, you always imagine the academic life is going to be full of discovery and wonder, and that didn't happen for me. Mostly just writing papers. But I feel like I had one decent insight in the 16 years that I've been doing this. And that is that, and it's going to blow your mind when I tell you, right? So, data analyses, turns out, are not naturally occurring phenomena. When you go and walk out on the street here, you're not going to accidentally trip over a data analysis, right? So they don't just run around wild. So what that means is that they are created by people, and they're created for people, right? That's it. That's it. 16 years to figure that out. So what that means is that, so in my experience, I've seen many data analyses go wrong, and often the problems can be traced to the people involved, communication, trust, things like that. And so that's often the source of a lot of failures. But it's also the thing that kind of binds all data analyses together. They're all done by people, they're all done for people. And so that, I feel like, is the start where we could build something that we can build a foundation for the field on. Grammar notwithstanding. So where the music comes in is that one of the things we learned in music theory is that for a long time we've been able to talk about different kinds of music, even music that has been written hundreds of years apart from each other, talk about how they're similar and how they're different. We can talk about the harmony and the melody and the rhythm and the style and the form. We can talk about how composers do certain patterns and how audiences like certain kinds of elements. And it's a very powerful form of analysis, and it forms the basis of music theory. And I think one of the things that's interesting about data analysis is that because the heavy role of people, it does have a kind of useful art flavor to it. And so that's the thing that we can use to kind of borrow from things like music, from art, to kind of build ideas around this foundation. So that's all I wanted to say today, that data analysis is probably more like art than we'd like to admit. And it's the basis that we can build kind of a set of core principles for data science.